How many solar panels do you think are down there? 100? 1,000? More? Big numbers are often hard for us to imagine.
This unit is going to equip us with the techniques we need to deal in big numbers.
So let's work out how to count the small stuff.
This is Real Chem. As chemists, we need to count particles, atoms, and molecules all the time. The difference between blood glucose levels in a healthy person and someone suffering from type 2 diabetes can be less than 1 millimole per liter. Having poor counting techniques may miss these differences, likely resulting in disastrous health outcomes. Yet even in a very small sample, like in this tiny sugar tablet, there are a huge number of sugar molecules, roughly a few sextillion. So clearly, we have a considerable challenge here. So how can we possibly go about counting things we cannot even see? Well, let's return to the solar panels. Say you wanted to know how many solar panels we can see right now. You might count the number in each row and then multiply that by the number in each column. This tells us the number in each block. Then we count blocks. This grouping is used everywhere. A dozen eggs, a six-pack of soda, a gallon of gas. The same trick works in chemistry, but instead of rows, we group particles into moles. A mole is 602 sextillion particles of something, anything. Where this number comes from is not the important thing. It's just a convenient number to group particles into when dealing with atoms and molecules, like a dozen is for eggs. So the mole is part of the solution to our problem of counting molecules. But because we are dealing with tiny things, atoms and molecules, there is another very important aspect of this. We have to use mass so we can measure it. If I wanted to count the number of sugar molecules in this tablet, I would simply get a balance and I would determine its mass. All you then have to do is divide this by the molar mass of sugar. Sometimes I might need to count molecules in this sugar tablet if it had been dissolved in water as an aqueous solution. This requires us to use a slightly adapted approach when we are counting. Again, these are standard techniques that chemists use to quantify big values.
Chemistry, of course, is more complex than simply counting solar panels. But this unit will provide you with the skills to work in a more quantitative way.
This unit starts with dealing with mole calculations and how to use these for compositional analysis and how to represent these steps in a formulaic way.
We then move into unpacking the composition of aqueous solutions, including calculating the concentrations of these solutions using molarity and other ways to record compositions. Throughout it all, don't lose sight of why it matters. Chemistry needs us to develop an eye for detail, despite the very big numbers. You can count on this being important. Now let's get to work. This is Real Chem.